for day 13, which is we're halfway through. I can't remember where I usually get up to in Advent of Code. Like, I think maybe around day 16, I'm like, you know what? It starts to get when it starts to get like past an hour for each puzzle or something. That's when I'm like, no, it's not worth it. I can do an hour after that, especially because it's near Christmas. You just want to chill out. Again, I have Chris with me, who will be making sure I don't make any silly mistakes. Although I will be sure to anyway. How are you all doing in chat today? How many of you have tried this puzzle? Yeah, I'm excited. Yesterday went well, so hopefully today will go well too. Day 13, distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, which is our puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. Okay, so we've got lists of lists. Oh, you know what? I was just telling Chris, like, literally just before the stream, I was like, we're talking about day 11, and that's like the not fun kind of parsing where you just have to do a bunch of nonsense. And if we get to write a recursive descent parser, that would make me happy. And this is like, you can write a recursive descent parser for this. So that's what we're gonna do.
I said surprise 25, but it looks like it's surprise 13.
Yeah. Okay, so we've got like recursive lists, reasonably straightforward format, it seems like. Main question is whether these integers ever go into double digits, but we will see. Packet data consists of lists and integers. Each list starts with a square bracket, ends with close bracket, and contains 0 or more comma-separated values with no spaces, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the right value is called right. The second value is called right. If both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. Otherwise, they're not. Otherwise, the inputs are the same integer, we continue checking the next part of the input. So it's like a lexicographic comparison of the list. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, we continue checking the next part of the input. Okay. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. Okay, so comparing a list of 3 zeros and 2, we convert the right value to a singleton list of the value 2. Okay. So this is one time where using C++ makes it a little bit more difficult for us, because with a dynamically typed language, you kind of don't have to care about the types of integers and lists. You can just write code. We need to do a little bit more work in C++. Using these rules, you can determine which of the pairs in the example are in the right order, and then there's a bunch of examples. If anyone wants me to run through them, we can, but it seems like reasonably straightforward. Lexicographic sort on lists. The left list has to, if the right list is longer, then that's greater than. On a mismatch, we make the integer into a singleton list. Okay, what are the indices of the pairs that are already in the right order? First pair has index 1, second has 2, so on. Okay. Hey, Brian RPG. Thanks. Okay, this seems like a nice puzzle. I like this. New day. So let's think about, we can use a variant to represent our our values. No, fever and sore throat, that sounds suck. That's, yeah, not fun. I hope you recover soon. So our value is going to store a std variant of either a integer or a std vector of values. And this should be allowed to be recursive because std vector can be used on incomplete types, right?
That's right.
We'll just call this data. And basically what we want is to implement bool operator less than for value LHS and value RHS.
Do we want less than or spaceship?
I think we just need less than, right?
Okay.
Like this is our ordering function, and we just need to decide if left is less than right. So this is going to be the actual like logic, and then we need to write a parser. So now, do these integers ever go above 9? Yes, they do. There's a 10 there.
That won't be too problematic. Are you concerned about that for lexing reasons?
Just because if we're just writing like a simple recursive descent parser, then if the integer is always a single digit, then parsing an integer is just return the integer minus the ASCII value of 0. Whereas if it's longer than one character, then you like multiply it by 10 and then go to the next one. So we can say we have a parse int function, which if we just parse all of these into std strings, we can just have a char star and just deal with it like that. So parsing an integer will be, we start off with 0 and
hold on. What if we used std I think it's 2int?
std s2i? Or
I think it might be a new one.
Well, there's a std 2int.
And maybe not std 2int.
There's like std from chars, but that's for floating point, right?
That wasn't the one that I was thinking of. I can't remember what it's called. Maybe
or std a to I.
Oh, I wasn't thinking of a to I, but effectively these are the. Or maybe it's toString that I'm thinking of. Sorry, I'm having a bad brain moment.
I mean, actually, the from chars might work fine. But anyway, yeah, we can just find like the walk forward until we find comma or a closing brace, and just do that. So end is going to be std find if from char up until we don't have an end here. No, let's like think about, before we just get into this, think about the main structure of the program. So we're gonna read all of our lines in, include get lines, TL views get lines of our input, a/life is going, and probably don't need to convert this to vector yet. But basically we're gonna get all of our lines. We can basically forget about any empty lines, and then get all of our pairs, and then filter the list by the pairs where the left-hand side is smaller than the right-hand side, and then we return the indices, the sum of the indices. So I guess that looks something like get lines, listed views, filter on return line is not empty. Oops. So we only want the empty lines. Then sorry, we only want the non-empty lines. Then we're going to chunk them into pairs. I have TLViews chunk. That probably requires this to not be an input range, though. So, oops. Convert it to a vector there, and then do lines piped into chunk on. So now that's our pairs. We do want the indices at some point, so we can enumerate this. So now we've got the indices of our pairs, and we've got the pairs themselves. Then we want to filter. Oops. Now, which order is enumerate again?
Hopefully it's index value.
Index value. Index value, yes.
The reason I remember that was because someone on Twitter was saying that earlier today.
Index value.
Oh, filter can only take a single parameter in its lambda.
Right. So this will be a pair. So we can use. I've got a thing.
Okay.
I have a thing. I have many things. I often find myself having like passing a lambda which we want to unpack a pair or a tuple into. So I have a thing called uncurry. Basically what it does is it's as if this took a std pair and then unpacked did like structured bindings or something like that. So you return if so v is going to be a chunk view. So something like, it's the easiest way to just get those two values out of get the first two values out of a range. What's the fastest way?
Normally since it's a random access range, because
it's not a random access range, it's a chunk view. At this stage, value is a chunk given by this, which returns a oh, it does return a subrange. A subrange is indexable?
Yeah. Subrange is whatever. A subrange will be whatever the iterator it wraps over is. So yes.
So we can just do that.
Mm-hmm.
So filter on the ones where v0 is less than v1, and then that will give us our or we can just get indices by taking the first value of the pair. Is there's something for that, isn't there? Std ranges.
Get the first value for the.
So
Sorry, can you please repeat?
There's like a std ranges keys.
Yes, the forgotten.
Takes a view of tuple-like values, produces a view with the value type of the first element. Okay, so that's our indices, and then we just do std cout tl sum our indices, and that should work. I mean, we need to parse our lines is the only other thing. So in here we do std views transform parse parse value from our line. Good, so we get our lines, we filter on ones which are not empty. There's a remove if, right?
Mm-hmm. Oh no, there's not. Sadly.
There's not a remove if. Okay.
There is one in range v3 which inspired standard ranges, but not in standard.
Cool. And then we parse all of the lines which were not empty. We convert this into a vector. We chunk this up into pairs. We enumerate them. We filter on the ones where the left-hand side is less than the right-hand side. We get the index, all the indices for those, and then we sum them up. So all that's left now is to write, why not a namespace str for std ranges? Yeah, it could do that. Would clean things up a little bit, but anyway, this will do for now. So we're going to write a parse value, which is going to take a std string or string view and we're going to parse this string into one of these. So we can, let's say, just take an iterator, so we're gonna start off at opening bracket, so we can just do plus plus it, and now we're gonna say if we are at an alpha, a number, what is the
Digit.
Is digit, that's it.
And that's in C type or CC type.
Yeah, it's probably included by one of these.
Okay.
If it's a digit, then we're going to parse an integer from this, and then we're just going to say return value with I guess a std vector of a single. Do we have lines which are literally just an integer instead of a list? It looks to me that every single line is a list of some kind, but maybe we shouldn't rely on my basic scan. But it does look like that, right?
Yeah.
Shouldn't be const char star, yeah, probably. Anyway, we're gonna edit this anyway. So let's just say, in case I made a mistake, we can do value, and we'll have a couple of constructors, one which takes an int. Oh, every initial left and right value is a list. Okay, thanks. And this will just initialize data with I. And then we have one which takes just a vector of values. And moves it in.
And we'll probably want to make those explicit too.
Oh,
Code
technically.
Code hygiene.
Yes. Okay. So we actually never get to this problem. In that case, we just want to parse a list. Then. So then all of our logic really is going to be in parse list. So this is going to return, say, a vector of values. So we'll construct a vector explicit, a value explicitly here. Parse list is going to take a start and an end, and what we're going to do is we will assume that we are at the opening brace. We will move past it if is digit it. So while we're not at either the end or closing brace, then we're going to parse members of our list. Yeah, we could do an assert here, like equals that, just for safety.
Also, that that first condition is back to front.
That first condition is back to front.
Yeah.
Well, it's not end. Thank you. Okay, so if it's a digit, then we're gonna parse a digit, so we're gonna have a std vector of values ret, then we're gonna do ret dot push back, parse int, otherwise we are parsing a list. So I guess we could say like it equals that. Otherwise we're parsing a list, and we're going to do ret dot pushback of parse list. Then we're going to let's assume that our parse int is gonna push both our parse int and our parse list is going to push it until the token after the character after the what is just parsed, in which case we can assert that we are now looking at either a comma or a close brace. Actually, we need to do different things for those, right?
Yes.
So now we're looking at a close brace. So we could be looking at a comma. If we are looking at a comma, we just want to move forward. if we were looking at a closed brace, then this would do nothing and we'd exit. And after this, we end up at a closed brace. Wonder what made you think variant here. What made us think variant here is because we have this is dynamically typed, basically. We've got a list, and each element of the list is either an integer or it's a list of either an integer or a list of either so on and so forth. So, like, because we're in C++ and we have to have static types, and we could do this with inheritance and all that stuff, or we could use std variant. Hey Vagrant, how's it going? Okay. Seem legit. And then our parse int is going to take that, and our end event is going to be std ranges find if from it up until end, and we're going to try to find C equals either a comma or C equals close brace. Is there a find first of or
There's
something?
a find first of. I don't remember if that's for. Ooh, maybe find first of would work.
Std find first of searches the range first last for any of the elements in the range s first to s last.
Yeah, so if we had like an array of 0 through 9 in character form, we could use find first of.
Oh, this is fine. This is going to return us an iterator to either end or the last position. So then we can do std from chars. What's that in again?
Charconv, I think.
Charconv, yeah, you're right. I assume this takes one past the end, and how do we tell it what type we need? We pass it, it takes an out parameter. Okay, so that should end up with our iterator not being moved, but we do want to move the iterator. So we're going to take these and do it equals end. Sound reasonable?
End or end of...
Sorry, yes. Cool. Find first not of std is digit.
That also works.
Yeah, this is fine though. That is nice though. Okay, so this should do our parsing for us. Let's just return true from here for now.
Also,
And
before you hit compile, you were right about not having explicit.
I was right about not having explicit. Why?
Yes. There are a couple of things that we did that explicit will stop us from doing.
Where?
I think with some of the pushbacks and one of the returns, the compiler will get unhappy.
True.
I just reckon we should delete the explicits.
I don't know. Like, you are right. It is a lot better to have to make it explicit rather than have implicit conversions
So if we want to
everywhere.
do things hygienically, should we use value there or use in place back? Or am I getting a bit too pedantic here?
Okay. Yeah.
I mean, if I'm being too pedantic, you
Yeah.
can.
No. You're right. In place back basically creates a new object of the type of the container, which the value type of the container, using these as arguments.
In that one, yeah.
Okay.
What's up with 2-vector?
I don't know. Sometimes IntelliSense gets upset. Or, well, and sometimes I forget to hash include it.
Import TL when?
Yeah. Std apply, no matching overload found. Did I make a mistake in my uncurry? What's this error? Callable is lambda, and our tuple is some tuple. You can see the mistake here. For now I can like get rid of that, and this takes a pair. That'll at least have a smaller chance of failing miserably. I just ran the wrong program. That's why it didn't do anything wrong. Std ranges keys. Do I need to construct that?
Keys might... I can't remember how keys works.
Did I just not hash include algorithm or something? Is keys an algorithm or is it ranges?
It's a view, not in ranges.
Oh, right. Std views keys. Hey Yosh, are you joining us from Japan or are you back? And I'm glad it's helping /life. From tries, no overload function could convert all the argument types. Why not? Oh, is it because I'm using like iterators and whatnot instead of
because it wants concrete jar star, doesn't it?
Yeah. Well, if I just use std s2i and just do a std string, does that work? Still in Tokyo for 2 days, nice. Okay, something's not returning a value. We actually need to return ret.
I find it weird that some things get formatted and others don't. Is that just with braces that formatting's happening?
It's if I'm that compiled. Basically, some of the nested ranges stuff gets a little bit confused. All right, let's see if we parse correctly, and then we can go about doing all of our.
Do we have an input file?
No, we don't have any input. Having input is always nice if you're expecting to use it. Okay, our lines is 16. Our first data is a vector of 5 elements with 11311. 11311. Yep, that looks legit. Our second is a list of 5 with 11511. That looks legit. Let's find a nested one. Next one is nested. 2 is... Wait, what was this? That looks wrong, doesn't it?
Mm-hmm. Oh, wait, hold on. Why does it look wrong?
It looks wrong because the size should be 2. So we definitely did.
Yes. Okay.
We definitely did misparse that list. Okay, so we parse this line correctly, we parse that line correctly, this one failed. So we should see... Oops. What just happened there?
Did we not enter? Can we see the condition? Oh, this one needs to be changed. This is we were saying if it's not a closed bracket, then and we're on a while, so we need to change it to a equal. Because we wait.
No.
No, that's right. What's going on here?
So our iterator and our
and it's an and. Should it be an or? No.
No, because we're saying, well, we're not at the end and we're not pointing at a closing brace. Oh, okay. It's just the debugger being a bit weird. Maybe it's because this is going to be move elided or something. Okay, so we're that's fine. So we are at a bracket. So then we're going to recurse, and then we are at digit. So we're going to parse 1.
I know what the problem is now.
Yeah.
It's we finished parsing this list and we don't move past the close bracket, and that means that when we exit the recursion, it's also going to see that bracket, and so it's only ever going to pass the first one.
Right. So this needs to.
Yeah. And that's why I also need to check the that we're at the end, not just at a closed bracket.
Yeah. Okay, let's just step to the end of this one, just to ensure that we actually no. Let's just step out here.
Yep, that looks good.
Okay. So what we're going to be returning, size 2. First one is
that looks good to me.
A list of size 1 containing 1, and then a list of size 3. Yeah, that contains 1. And then a list of size 3 containing 2, 3, 4. Okay, this looks reasonable to me. We could just like write an output and like a formatter to this, but this looks reasonable. Okay, so now we just need to implement the logic here. So Chris got in yesterday morning. So here's where we're going to use our variant. Did overload get into C++ 20?
I don't. C++ 20, no. C++ 23, I don't know. And if it is in C++ 20, I'm going to be surprised Pikachu face.
So std overload was this thing which makes visiting variants with lambdas a little bit nicer. So you can just pass a bunch of lambdas which take different types, and it all just works. And I'm just going to steal this implementation because this isn't like an entire implementation. I will explain how this works. It looks a little bit janky, or well, a little bit weird. I'll show the usage of it first, and then I'll explain how it actually works. So we're gonna return std_visit. I always forget the order. Okay, callable and then the variants. So our variants are gonna be LHS and RHS, and then we're gonna pass in something which a callable object which will essentially do multiple dispatch, will double dispatch on our LHS and our RHS. So what this is going to look like is we're going to say overload, and we're going to have a few lambdas here. So we're going to have one which takes an int, and we call these L and R. An int and returns whether L is less than R. And then we're going to have one which takes a std vector of values and a std vector of values and returns. Can I just do is there a lexicographical ordering for std vector which will just work for this?
Yes.
Yeah.
We may want to make pass them by reference though, not by copying.
Yeah, true.
Constant ref.
Whoops, thank you. Silly mistakes we make. And then we want one which does an int on the left hand side. I believe we have to do both of these, right?
Mm-hmm.
But we can essentially do... What's the easiest way to do this? We want to turn into a Singleton list, so we can just create a new value with a std vector of integers with L as its single member, and return whether that's less than R. Right?
Yes.
And then the other way around, there's probably some machinery you can write which will handle this essentially duplicated condition, because you're wanting to do multiple dispatch but not really care about the order of these. But anyway, L is less than that.
Oh, that's what. Okay, there's an extra brace that we need to get rid of.
Extra brace where?
Before return.
Before return, yeah.
Because ideally these two should be blind.
This is complaining, but maybe it might be IntelliSense, we'll see. Alright, so I'll explain overload and visit a little bit. So basically, std variant is, it's kind of like a union, right? This is, we say an object of, our data object is either going to contain an int or it's going to contain a vector of values. And then we don't have pattern matching in C++ yet. C++ 26, maybe? 23?
I make no promises on that.
We don't have pattern matching yet, but we can kind of do it like this. So what we do is we have this overload thing, which we pass a bunch of lambdas, well, closures, technically. This overload inherits from the types of all of those lambdas. So the lambda class is just this generates a class which has an overloaded call operator. This thing. So what we do is we inherit from all of those lambda classes which the compiler generates, and then just expose all of those call operators as overloads. So basically you take a bunch of closures and you turn it into an overload set, which is kind of cool. Like, we shouldn't have to do this if we had proper pattern matching in the language. We wouldn't have to do this, but for the sake of like trying to get something which works for this kind of visitation, I think it's kind of nice. So the inner operator less than gets called twice when it encounters two equal objects. When it encounters, in this case, when one is a integer and one is a list, then it will recurse. Yes. Is it meant to be std vector value L instead of std vector int L? No, because we're constructing a value whose data consists of... Oh, right, I see what you mean. We need to have, like, multiple levels of this. It's kind of... It's getting a little bit icky, isn't it? But, oh, you're right. We don't need the outer value because L is just a std vector. Yes. Okay, yes. You were completely right with what you said. Yes, thank you. This just needs to be std vector of values which we construct like so, and this needs to be the same. Okay, and that does make our error go away. Thanks for that, Ali1331. Our std visit is saying, "Oof, what you trying to do?" We'll compile it and see. Okay. No matching overloaded function found. Why not? Could not deduce the template argument for ret.
If I name symbol, that's fun.
Do we need to give these?
We don't need to. No, because they're all returning bool. That should be very easily worked out.
Would hope so. One thing we can do is in case our overload thing is just kind of screwing up, let's try calling this with like 0, 0 and see if overload resolution succeeds.
Okay,
it does.
Works. What if we just enumerated all four one after the other and did one compile?
Okay.
We need vector value.
Yeah.
Zero comma vector.
I've got a syntax error here. What are my parentheses doing here?
So you got to put the 0 at the front of the function parameters. Yeah.
So this is just making sure that all of my overloads compile. They did.
Okay, that's weird.
So
Is there something else?
if that's the case, why is std visit failing? Anyone seeing the issue? I'm supposed to say no matching overload found. Could be this std visit actually have more than one overload. It has, okay, since C++ 20 it has a single overload, and it couldn't deduce the type of R. Use LHS.data and RHS.data. Yes, thank you. Because we weren't actually passing in variants at all. We were just passing in our values. All right, cool. Let's see how we go. Just get rid of all of our breakpoints and run it and see if we get the right answer for the test. 9. 13. Well, that's not correct. So we're making progress, but we're not there quite yet. Let's stick a breakpoint in. Stick a breakpoint in our in here and see where we go. Off by 1 error. Yes. You're right. The indices in the question are 1 based.
Thank you to whoever pointed that out.
Yeah, thank Masvo. +1. Whoa.
Oh, that's what happened.
And then if you try to save like while compiler's going, then it's like, what are you trying to do? Oh, and it's gonna happen again, isn't it? Yes, it is. Okay, got rid of my silly syntax errors, hopefully. All right, let's give that a try. Let's just run and see if we get the right answer. 13. Huzzah. We're still in part 1, but I'm pretty pleased with the solution that we've got. It's nice. Using variant for this is it works pretty well. All right, got my answer on my second screen. 5623. That's the right answer. Success. Okay.
Yay.
Now you just need to put all of the packets in the right order. Disregard the blank lines in your list to receive packets. We did that already. The distress signal protocol also requires you include 2 additional divider packets. Using the same rules as before, organize all packets, the one in your list of received packets, as well as the 2 divider packets into the correct order. Okay. Afterwards, locate the divider packets. To find the decoder key for this distress signal, you need to determine the indices of the 2 divider packets and multiply them together. Okay, this doesn't seem like too much extra work, right? We basically let's just copy paste all this for now. So in our lines, we're not going to do all of this stuff. We are going to collect a vector of our lines, and then we're going to push those 2 divider packets, lines.put in place back, and it was a list of lists containing a single list. let's just make pack1. So this is going to be, I could very easily construct this wrong. A value which is constructed from a std vector of values whose member is a std vector of values whose member is a 2. Right?
Mm-hmm.
And pack2 is the same. You know what, can I just ask this to parse me? Oh, I've got parser. I can just use parser, right?
I did wonder that. Can we do that? Because what happens if we have a triply nested list?
Should be fine.
Or a doubly nested list with... You think we can still get
I think I can just say parse value 6. And parse value 2.
Okay.
And I don't have to construct it myself. Just get the... We already wrote the code. Let's make it do something. So that should... we technically don't need in place back there now. That should push back our divided packets. Then we do std ranges sort of our lines. And then we find the indices of our 2 packets. So let's just, yeah, because we're going to use these later. And okay, so we're going to sort our lines, and then our answer is the multiplying the indices together. The first packet is index 1, so again, making sure that we're not getting an off by 1 error. We can do we need a whole sort. Std partition would have we could do a std partition. I'm just gonna do a whole sort for now. We can think about optimizing it some other time. We're almost at an hour. So. Oh, we'll give you better complexity and give you the position. You know, this is fine. Pack1 location is going to be std ranges find in our lines of pack1. Pack2 location is going to be the same. And our answer is going to be distance from beginning of lines to pack1 location +1 times the distance to our second pack. Look right?
Is it... So, I am still a bit fuzzy on what it is that we need to do here, but...
We're getting the index of this pack, the index of this pack, and multiplying them together, and the indices are 1 based, so we're adding 1 to them.
Gotcha. Okay, that looks right, yes. Yeah, see how it's going to complain, though.
No matching call found. Why?
What's the type of lines?
Lines should be a vector because I convert it to a vector. Vector sortable evaluated to false.
It's a vector of strings too. No, it's a vector of values. Values has a less than, so why is it not?
Parse value returns a value. Does sortable have more requirements than operator less than?
Sortable requires it to be. Let's just look it up.
Permutable and strict weak order. Indirect strict weak order just requires
Yeah, we meet this requirement. And all the others are going to be met as well. Can you look at immutable, please? Yeah, we should be those.
Is it because we don't have a move constructor or copy construct? It says indirectly movable, indirectly swappable.
So I can't remember the rules for aggregate types, but that should.
This isn't an aggregate because it's got
right
constructors.
But those are both copyable and. With GCC and Clang, I know you get the full trace of the concept requirements not being met. Does MSVC give us that?
We're starting to yeah, you can see it starting. Okay, actually, it's telling us here indirect strict weak order of stood less evaluated to false with our type as value.
Mm-hmm.
So what is the indirect strict weak order?
Okay, because strict weak order evaluated to false. That's interesting. I'm surprised by that.
And strict weak order did all of
Relation,
these
because
evaluated to false.
Invocable evaluated to false. Why is invocable failing?
Because the expression is invalid. We must be doing something like really silly. Anyone see the very silly thing which we are probably doing? We're just trying to do a std sort on our lines. Like, does this work if we do the unconstrained version? Well, std ranges find won't work because we don't have an equality operator, right?
For value, yeah. Single equals.
Whoops. Oh, that was the entire problem. Cool. Then we can get rid of.
Why does sort need equality?
Interesting. So for some reason our ranges sort fails, but regular sort compiles.
Do we need to do something with 140, or was that just for the specific example?
That's just the example. Okay. That's our answer, yay.
Nice.
I do want to know why that didn't work. So,
yeah.
Is it because we need the other comparison operators as well?
Oh, yes, because std ranges less requires us to have something that's totally ordered, and totally ordered means that you have not only less than, but literally all the comparison operators except for spaceship, which is optional.
Is there a way with spaceship operator to say
just change it to spaceship, and then so if we change it to spaceship, then we do return auto. And then instead of return std visit blah, we may need to change this. Let's use spaceship inside all of our lambdas. Hopefully that will work. Nope. Okay, the interests of how much time do we have left?
5 minutes over what I usually am at.
I mean, the fastest way to solve this would be to just implement the other three comparison operators as not less than, or in the three normal forms.
Mm-hmm. It's not pretty. But anyway, I'm happy with just using std sort there. It's fine. Cool. I'm pretty pleased with that.
Mm-hmm.
We got to write a recursive descent parser. We got to use std variant. We got to use our overloading lambda types. Yeah, cool stuff. All right. Thanks everyone for joining, and we will see you all tomorrow.
Bye-bye.